Hi guys, welcome to Pre-Calculus 11, Chapter 1.3, Geometric Sequences. Once again, we'll start off with PLOs. First PLO for the day is to provide and justify an example of a geometric sequence. We have to derive a rule for determining the general term of a geometric sequence. And, as always, solve word problems that involve geometric sequences. So we've already done arithmetic sequence, but what exactly is geometric sequence? It's again a pattern of numbers, but this time it's with a common ratio. With an arithmetic sequence you added or subtracted the same number each time, but with a geometric sequence you would either multiply or divide the same number. So let's take a look at this example. We have 2, 4, 8, 16, 32. There's a common pattern between all these numbers. You multiply 2 to get to the next term, and so that'll be our ratio. For the general term formula for a geometric sequence, it's written as T of n equals term 1 times r to the power of n minus 1. I'll explain each of the variables. T of n is basically the answer you're looking for. It's the answer for the nth term. T1 is the first term of the sequence, so number 2, as from the example above. Ratio is the number you're multiplying by, so for this it would be times 2, so the ratio would be 2, and then n is the number of terms in the sequence. So let's have a look at our first example. As you can see, the first example is 3, 6, 12, 24, 48, and so on. So first let's see if there's a pattern. From 3 to 6 you multiply by 2, from 6 to 12 you multiply by 2, and that's the same for everything else. So we found out that our ratio is 2. So A is asking us to write the general term formula. So we start off with our formula, T of n equals T1 times r times n to the power of 1. And now we just fill in everything else. So T of n remains the same, our first term is 3, and our ratio is 2. So our final answer would be T of n equals 3 times 2 to the power of n minus 1. And you can just substitute a number for n to find out any term in the sequence. Now it's asking for us to find a specific term, term 12. So we use our formula, T of n equals 3 times 2 to the power of n minus 1, and we just put in 12 for both the n's to get a final answer of 6,144. So that just means that the 12th term in this sequence is 6,144. Moving on to question 2. This gives us two pieces of information. Term 3 is 54 and term 6 is negative 1,458. And there are two questions. First is to find the ratio, which is what do you multiply by, and it's to find term 1. So let's first find the ratio. Now, if you think logically, to get to term 4 from term 3, you have to multiply by the ratio once. To get to term 5 from term 3, you have to multiply by the ratio twice. And to get to term 6, which is what we're looking for from term 3, you have to multiply by the ratio 3 times. So the formula we get is, to get term 6, you have to multiply term 3 by the ratio 3 times, so which is just T3 times r cubed. So let's fill in the information. T6 is negative 1,458. T3 is 54, and then we have r cubed. Now we want to solve for r, so let's first get rid of everything else on this side. So let's get rid of the 54. Divide both sides by 54. You get negative 27 equals r cubed. How do we get rid of the cube sign? You have to cube root it. So when you cube root negative 27, you get a ratio of negative 3. That means you multiply by negative 3 each time. Now let's work logically again. To get to term 2 from term 3, instead of multiplying by the ratio, you have to divide by the ratio. And to get to term 1 from term 3, you have to divide by the ratio twice, so r squared. Now, so we don't know what term 1 is yet, so we leave that. Our term 3 is 54 divided by the ratio squared. So negative 3 squared gives us 9. 54 divided by 9 gives us a first term of 6. This is a word problem. So a ball is dropped from a height of 3 meters After each bounce, it rises to 75% of the previous height. That's the key variable of their 75%. So A is asking us to write the general term formula. Again, always just write down the formula in the beginning. T of n equals T1 times r to the power of n minus 1. And just fill in T1 and r. We know that the first term is 3 because it's dropped from 3 meters. And every time it bounces, you get 75% of the original of the number from the bounce before. And then we leave n because that's the variable you want to substitute. And now the question is asking, how high will the ball bounce after the 6th bounce? Now you have to remember one thing. After the 6th bounce is technically the 7th term because the first term is 3. And after the first bounce, it's actually the 2nd term. So it'll be 3 times 0.75 and so on. So after the 6th bounce, it's technically the 7th term. So that's a little bit tricky. Watch out for that. So start off with our formula. T of n equals T1 times r to the power of n minus 1. Substitute n, we want term 7, and substitute n over here because it's term 7, and you get a final answer of 0.53 meters or 53 centimeters. Rounded. Last question for this section. When you wash clothes, the color of the clothing fades. Suppose a pair of jeans fades by 5% each time you wash it. What percent of clothes remains, that's the main question, after 10 washes? So you want to start off with the T1. So if we're using percentages, we'll just start off with 100% as our T1. So we'll substitute T1 as 100, and the question's asking how much remains. So if 5% is faded, we know that 95% remains, so it'll be 0.95 as our ratio. And then now they're asking after 10 washes, so we just substitute 10 for the number of terms. And once you multiply all that, you find out that after 10 washes, 63% of your original gene is now remaining. And that's the end of this section. I hope you found it helpful. Thank you very much.